Today's the day. We're off to visit our beneficiary lab. We're going to meet Dr. Raju, who is working really hard to cure medulloblastoma, which is the brain tumor that my son Drake beat.
We're really excited. We're going to get an update on his research, what he's working on, what he intends to use the money for. The money that we raised at our 2018 event, the money that you helped us raise, and your support of our event made possible.
It's going to be a great day. We'll keep you posted. More to come.
Okay, we're walking out the door. Getting in the elevator.
Hi, my name is Raju. I'm an attending pediatric neurologist at New York Presbyterian Hospital, Komansky Center for Children's Health, and Weill Cornell Medicine. I run and direct the Laboratory for Childhood Brain Tumor Research. We are trying to identify new and improved treatment strategies for children that are affected with brain cancer. Although we've done a really nice job in the last several decades improving the survival of children who are afflicted with brain tumors, one of the problems that I noticed was that the toxicity that we often have to provide or the children have to endure when treating these devastating diseases is quite severe. The tumor that we study is known as medulloblastoma, and it's the most common malignant brain tumor in children. There are nearly 500 or so children every year in the United States that are afflicted with this, and despite very extensive treatments including surgery, whole brain and spine radiation, and various forms of chemotherapy, still up to 70% of the children that survive have very severe toxicities, and these include neurocognitive problems or intellectual disability, as well as growth and endocrine problems. One of the big limitations in studying or identifying better treatments for cancer are that we use very artificial models to test drugs. With that has become this big conundrum where almost 95% of drugs that are tested and proven to work in the lab never actually work when you actually get to human patients. Only 1 in 19 or 5%. And I thought that was a really big problem. Of the 5% that actually make it through what's called the FDA clinical trial process, those often have a survival benefit of often only 6 months to about 1 year. At best, you can imagine that that's not really good enough. And it's gotten so expensive here in the United States where a single drug could cost up to over $1 billion to go through the whole process. You can see there's a lot of inefficiency in the system. So the way we decided to approach it was, well, if we wanted to study model systems that look like cancer that occurs in children, we should try to make those model systems look as close as possible. For example, medulloblastoma has many features. One is that it metastasizes, and what that means is the cancer cells often move from the original site in the brain along the surface of the brain into the spinal cord. However, in the last 20 years or so, the animal models that people have used to test drugs against medulloblastoma often don't even metastasize. And if this is what ultimately results in the demise or death of children, I don't think we're making that bench-to-bedside research transition that everyone really hopes for in scientists. What I hope to do is then to use these animal models that are more like the human disease to then make the process of identifying drugs at the bench more likely to be efficacious when we actually make it to clinical trials. With an approach like this, then hopefully the costs that are often endured by the American public can be minimized. We think that ultimately it may improve in the outcomes of children who are afflicted with brain tumors such as medulloblastoma. And hopefully our approach might be useful for not just pediatric brain tumors, but for other cancers in general that afflict the population as a whole.